Hi everybody, Dr. Charlton here again. It looks like my last video about Rstudio was not very it was not very YouTube friendly, so I apologize for that. This whole change to online classes has been a learning experience for everybody. So thanks for all of you who let me know that the resolution was a little bit low. So I'm gonna kind of re-go through a lot of the stuff I talked about in the last video, just to make sure that you can see it good on here. So you can see on my screen I have hopefully a higher resolution where you can a larger, set of things so that you can see what's going on. So let me go ahead and jump right into this. So first of all, I have all my code in here, but I'm going to go ahead and start with the same thing that you all have. So if I go to Scholar Dash and I'm going the research, so for week 13, there's some uh, code. So I'm going to go ahead and probably just copy this code and I'm going to paste it right here. So I have the same thing that you have to start with. So first of all, I'm going to clear out all my existing data sets, make sure I have a clean space to work with. And then I'm going to go ahead and first of all, I want to look at my data set and see what's in it. So all I have to do is put my cursor by it and then I'm going to hit Control Enter, or I can just hit Run, or I can select it and hit Run. So there's several options. So I'm just going to put my cursor by it and hit Control Enter. That seems to be the most efficient. And this has all my data set outputted. Unfortunately, it outputted my last column to a new row because the screen wasn't real wide enough. So I'm going to run it again so I can get it all together. You see how it's all together. Before it had carb was on its own kind of own row. So now I have all the data. So let me also just run this help file to see what's in mtcars. So you can see here's a description of all my variables and this data set. It's from 1974 for 32 automobiles from 1973 to 74. So I have various variables. They're all, abbreviated here, of course, and right here they're in more detail. Basically, I'm just going to, I can just run, I can run a regression. So this is my regression syntax. So LM means linear model. It means I'm going to run a regression. And I always want to put my outcome variable right here. So miles per gallon is what I'm really interested in. My goal is to maximize miles per gallon. So I do the tilde. So that's in the upper left part of your keyboard. So miles per gallon is predicted by two variables. I have weight, which means weight by 1,000 pounds. So if my number for MozRX4 is 2.6, that means it's 2,600 pounds, right? And then I have HP, which is gross horsepower. So if my HP for Mazda RX-4 is 110, that means my horsepower is 110. It's not like scaled by 1,000 like the weight is. Okay, so my data set is mtcars. So this is all the stuff that you need to run regression. Now I can run this by itself, which I'm going to do right now. So I have it all selected. Control Enter. I run it. And this is what happens when you run a regression formula, when you run this regression model. It gives you some outcomes in terms of these are the coefficients. So as weight goes up by 1,000 pounds, so for every 1,000 pounds of weight, because remember weight is scaled by 1,000 pounds. So if weight goes up by 1,000 pounds, then horsepower goes down by almost 4. Not horsepower, miles per gallon goes down by almost 4. So and then horsepower goes down by 0.03. Okay, sorry, As horsepower goes up, miles per gallon goes down by 0.03. Does that make sense? So I'm going to actually need more data though. This is only showing a limited part of the data. So I'm going to save this as model 2. So I'm saving my whole regression formula now as this variable, as this container called model 2. Model 2 has now become a synonym for all this stuff. Okay, so model 2 is the same thing. So if I run model 2, it gives me this. And if I run this regression model, it gives me the same thing. So now these two are completely synonymous. So now I'm going to do a function. I'm going to execute a function called summary on my regression model, which really means I'm going to get a summary of this whole thing, right? Because model 2 is a synonym for this whole thing. So I'm going to go ahead and run that, see what I get. Okay, so I did give you a cheat sheet for interpreting this, but I'm going to walk you through it just to make sure that you understand the key things. All right, so my most important part that I care about are these coefficients right here. So as weight goes up by 1,000 pounds, miles per gallon goes down by almost 4. As horsepower goes up by 1, miles per gallon goes down by 0.03. Okay, so let's see if they're significant. Now the p-values are over here. This right here is a p-value. It should say p-value. It doesn't. It says something else that's probably more correct but less clear. Okay, so this is scientific notation right here. 1.12, this should be 1.12 times 10 to the negative 6 is what this means, essentially. So anytime you see the e here and there's a negative exponent, just recognize that it's a very small number. And these stars help, right? Because the 3 stars is telling you that it is less than 0.001, right? Okay, so they're significant. This is less than 0.001. This has 2 stars. It's less than 0.01, okay? So these are both significant. They're both less than 0.05, which is kind of like our significance cutoff. Generally, if things are less than 0.05, we say they're significant, but there's different levels of significance, right? 0.05, 0.01, 0.001. So there's different numbers of stars. So it's like, it's like significant at this is significant at p is less than 0.001, and this is p is less than 0.01. So anyway, it really just needs to be less than 0.05 to be significant. These are both significant predictors of miles per gallon. So the weight does matter. The horsepower does matter. Both increased weight and increased horsepower decrease miles per gallon. I think that's intuitive, right? But now we have the data to show it. We run it through our regression model. The next thing I want to show you is r squared. So if r squared is 8.268, that means 82% of our outcome variable, 82% of our outcome variable can be explained by these 2 variables. This one and this one, okay? 82%, almost 83% of it. So if you tell me how much your car weighs and what the horsepower is, I can predict your miles per gallon with about an 82% certainty, because there are other variables, right? There are other things I haven't considered. Even if we include all these variables in the model, there's probably other things not on here that can affect, how much gas mileage you get. So we're not going to have like the 100% explanation. Now this is significant because we have a p-value that's way less than 0.05, right? So it's the exponent is negative 12. This is a very small number. Okay, so this is, interpreting a regression output. These are the coefficients right here. The coefficients are significant. this is the R squared, which is the overall model fit. We often like to look at an overall model. So how does, you know, all this stuff affect our outcome variable? And this is the answer. It says it predicts 83% of it. Now we can graph that out and see with an 83% prediction rate, that tells me that most likely, all right, so most likely when I graph these variables out, they're going to give me a pretty straight line. I have a plot here that has an outcome variable. So the data set is mtcars, which is our data set we've been using. The x variable, which means the predictor variable. In this case, I have the displacement loaded up, but I actually want to probably get weight. And over here, I'm going to do mpg. So how does weight impact miles per gallon? I'm going to go ahead and graph that out. I bet you most of these dots fall pretty closely on the line. And they do. The reason why is because as cars get heavier and heavier, they reliably get worse and worse gas mileage, is what that's saying right there. The other variable I was using is horsepower. So it's probably the same thing, right? As horsepower increases more and more, gas mileage is probably going to go on the decline very reliably. See that downward, reliable, consistent trend. I can actually get three variables in here. So if I do, I'm going to add a color variable. So on color, that's the New Zealand spelling. This is New Zealand software from New Zealand. So color equals, and then I'm going to add my other variable in there, which is going to be, again, weight. Let's see how that does. Okay, so you can see the lighter colored ones are heavier. So you can see how it goes from darker up in the upper left down to lighter in the lower right. And you can see how, the ones that drop below the ones, so you have two kind of outliers here that kind of fall off of this line. And you can see that's because even though their weight, their horsepower should put them right here, but they're really heavy. See, they're really light color, so they're down here. So anyway, that's basically how to do a regression in using R. It's pretty straightforward. You can do a lot of different things with it. You can just substitute in variables, put whatever variables you want from the model in here, and you get a different plot. One thing that we were looking at earlier was how number of gears affects the miles per gallon. So I can go ahead and plot that out. And you can see the number of gears does have an effect between 3 and 4, but over here it's not as clear at 5 gears. It's just not as clear. So anyway, but it does, the number of gears, I think because with increased gears, the motor operates more efficiently. So it's able to run at a more optimum engine speed. So you're saving gas that way, if that makes sense. Something to look at when you're trying to buy a car. Maybe look how many gears there are. It could make a difference. Although they'll tell you what the gas mileage is. So that could be what's influencing it. All right, so that's basically taking you through. Now you have a homework where you're supposed to do a different model. I'm not going to do that for you, but I can tell you that basically you're just going to figure out what the variables are, and I believe there's one that's like engine volume, which is I say it's engine volume, but in parentheses I say it's DISP, so displacement, and I can't remember what the other variable was, but basically you're going to substitute in predictor variables right here and your outcome variable that you're interested in right here, and then just run this model and then see what kind of outcome you get. And then don't forget to look at the cheat sheet that lays out how to interpret the syntax. That's going to really help you when you go to do the assessment. So that's all I have. Hopefully this makes the last video more clear. Hopefully I didn't leave anything out. Let me know if you have any other questions, and have a good rest of your